Good afternoon, students. So today we see one more type of nonlinear equation, that is f1 of xp is equal to f2 of yq. Okay, so in this case the equations only p, x and yq are present. So this type of equation, it is denoted by f1 of xp is equal to f2 of yq. Now to solve this equation, what we do? So in this equation we put each side of equation is equal to a. That is, we consider or we take f1 of xp equal to f2 of yq is equal to a. Okay, so we equate each side of the equation equal to some constant, that is a. Now solving these equations for p and q, that means on solving this equation, so first what we do, we take the first term, that is f1 of xp equal to a, then we solve that for p and q. For p, then we get the first solution as p is equal to f1 of x. Next we take the second equality, that is f2 of yq is equal to a, and again we solve those for q, then we get the solution q is equal to f2 of y. After getting the solution, so the next thing is very simple, that is we know that by the total derivative formula, we can write dz as dou z by dou x dx plus dou z by dou y dy, so which is equal to dou z by dou x means p dx plus dou z by dou y means q dy. So that is dou z is equal to dou z by dou x means it is p, so p means we have got the solution p as f1 of x. Next dou z by dou y means q, that is q is equal to f2 of y. So then we substitute all this p and q in this equation and we obtain this equation. After obtaining this equation, then the next thing is to integrate it. So integrating, it gives integration of dz is equal to z, which is equal to integration of f1 of x dx plus integration of f2 of y dy plus integration constant b. So this is the solution of the given nonlinear equation. Okay, so this is the method of solving a nonlinear equation of the type f1 of xp is equal to f2 of yq. Okay, now we see some problems on this. So first example is given as solve p square minus q square equal to x minus y. Now this is of the form f of p x is equal to f2 of qy. Okay, the equation contains px and qy. So now this equation can be written as, bring this x here, that means bring this x nearer to p, and bring this q to other side, so that make sure that p and x should appear on one side, then q and y should appear on another side. Okay, so now this equation can be written as p square minus x. So I take this x to here, then it gives p square minus x, then I send this minus q square to RHS, so q square minus y. Now which is of the form f1 of xp is equal to f2 of yq. Okay, so now what we do, we assume that p square minus x is equal to a and q square minus y is also a. Now for considering the first one, that is p square minus x equal to a, then p square is x plus a. In the same way, q square minus y is equal to a means q square is y plus a. So that means p is equal to square root of x plus a and q is equal to square root of y plus a. Now substituting these values of p and q in the equation dz is equal to p dx plus q dy, then we obtain this equation dz is equal to root of x plus a dx plus root of y plus a dy. Next is integrating. So integrating with respect to x on both the sides, so this gives z, then integration of this is 2 by 3 x plus a whole raised to 3 by 2, then plus integration of this is again 2 by 3 into y plus a whole raised to 3 by 2 plus p, which is integration constant. So this is the complete solution of the given problem. So this is what a simple problem. This is what a simple problem. Simple problems means what? The given problem, it is already in the standard form. It is already in the standard form and no need to reduce that into a standard form. It is already in the standard form, therefore the solution is very simple. Whereas when what happens, sometimes the given problem is not in standard form, then at that time we have to reduce that equation to a standard form. So therefore solve the second problem is an example of this kind. Solve yp is equal to 2yx plus log q. Okay, solve yp is equal to 2yx plus log q. Now in this case the given equation can be written as, now see here, this can be written as dividing throughout by y, so p is equal to 2x plus 1 by y log q. Dividing the whole equation by y, then p is equal to 2x plus log q into divided by y. Now I bring this 2x to near p, so p minus 2x is equal to 1 by y log q. Now this is again of the form f1 of xp is equal to f2 of yq. Okay, so this gives, so now this gives integrating p is equal to 2x plus a and q log q is equal to ay, that means q is e raised to ay. Now substituting this p and q in the formula dz is equal to p dx plus q dy here in this equation, so which gives a dz is equal to p means 2x plus a dx plus q means e raised to ay dy. Next we integrate this, we get z is equal to x square plus ax plus 1 by a e raised to ay plus b, so which is the required solution. Okay, so next we have another type of problem, that is solve z square into p square plus q square equal to x square plus y square. Now in this case the equation can be written as, now multiply this z square with this terms in the bracket, so it is what, z square p square plus z square q square equal to x square plus y square. Or in other words, p means dz dou z by dx, then q means dou z by dou y. So the equation can be written as z dou z by dou x whole square plus z dou z by dou y whole square is equal to x square plus y square. Now here we make the substitution as, let z dz is equal to d capital Z, so that capital Z is equal to 1 by 2 z square. Okay, because integrating both the sides, so integration of dz is z, which is equal to integration of z dz is z square by 2. After getting this, then dou z by dou x means dou capital Z by dou x can be written as dou capital Z by dou z into dou z by dou x, which is equal to dou z by dou x as it is, dou capital Z by dou z is, differentiate this with respect to small z, so dou capital Z by dou z is equal to this 1 by 2 constant, integration of differentiation of z square is 2z, 2 to get cancelled, so it is z. So therefore this is z dou z by dou x, and similarly we obtain dou z by dou y as z into dou z by dou y. Now substituting all this in the given form, which gives z dou z by dou x, already we have that, which is equal to dou z by dou x whole square plus z dou z by dou y, which is here z dou z by dou y is equal to dou z by dou y whole square equal to x square plus y square. Or let us denote this whole equation by capital P and this derivative by capital Q. Then it gives p square plus q square equal to x square plus y square. Okay, so then bring this term x to here and send this q square to here. We get p square minus x square equal to y square minus q square, or which is of the form f1 of xp is equal to f2 of yp. So from this equation calculate p. P is root of x square plus a and q is root of y square minus a. Okay, q is y square minus. Now substituting this value of p and q in the equation, dz is equal to p dx plus q dy. So we obtain this. Then integrating both the sides, capital Z is equal to, we get 1 by 2 x into square root of x square plus a by 2 log of x plus root of x square plus a plus 1 by 2 y into square root of y square minus a by 2 log y plus square root of y square minus a plus b. Okay, so this is the complete solution of the given problem. Okay, so these are some exercises, these are some problems are there. Okay, so which are based on these 4 kinds of non-linear equations. Okay, so now try to solve these problems. Okay, try to solve these problems. The answers are given here, so you can verify your answers after solving this these problems. Okay, so all the 4 types of non-linear equations are completed, and with this I conclude this class and continue in the next class. Thank you.